Hello everyone, and welcome back to our 7th video for the Intro to Programming section. In this one we're going to be covering functions, parameter passing, and we're going to end it with a pass by value. So what is a function? A function is a segment of code that you call within your main, and it's going to exit the main portion, execute this section of code that you just gave it, and then return back to the position where it just left off at. A function also has the power to return something of a specified type back to the user. That is called a return type, and we'll explain what that is. But our introduction to that is that we use int main, and then at the bottom of our programs we return 0. We're returning an integer back to our main program. So that's an example of what a return type is, but we're going to get a much more in-depth look of how functions can return a specific type. So getting into our return types. A function will execute the code within its scope. It then has the power to return something back to the function call. Whatever return type the user uses is the type that the function can return. So let's look at these two. We have the int is our return type, which means this function can only return of anything that is an integer value. And then we give it our own specific name. We're going to call this add5, and this here is called a parameter. So you can pass in however many parameters as you choose. You can also pass in any type of parameter. In this instance, we're passing in an integer, but I could pass in a string, I could pass in a character, a double, I could pass in whatever type I want. The parameter type does not need to match the return type at all. These are two completely separate things. So in this instance, I'm passing in an int and we're calling it number. So the first and only line of code is its return value. It's going to return the number, whatever we passed in, plus 5. Hence the name is in add5 is the name of the function. So let's say, for instance, we pass in the number 10. So in our int main, we go and call add5 and we pass in an integer that holds the value of 10. Now what it's going to do is it's going to come into the function and it's going to replace the number with the value of 10. 10 plus 5 equals 15. It's going to return an integer of value 15 back to the user. Now let's look at the same block of code over here, but this time we broke it up into two different lines. So same thing, return type of integer. It's an add5 function passing in an integer titled number. So again, our equals is an assignment operator that is read from right to left. So our number, which holds the value of 10 in this instance, plus 5, so 10 plus 5 is 15, that is now being stored in the number location and in our number variable. And then again, we are returning the value that we have stored in number back to the user. Now there is something called a void return type, which means the function will not return anything. So instead of int, you would write void. And just to specify, you can put whatever return type you want. It doesn't have to be an integer. It could be a string, it could be a character, it could be a double, it could be a boolean, or it could be a void. So next we're going to get into prototypes. This is where you put the name of a function at the top of the file. This is going to be done above the int main section. So you have two options with your prototypes. You can either put everything above the int main, which means your function definition, and this is an example of a function definition. I have the entire function and I'm defining it within its curly braces, so that's called a function definition. So I can either put the function definition above the code, or if I choose to put the function definition below the code, which is what I've always done, then you have to put a prototype above. I'm sorry, we should be here, sorry. Then you want to put a prototype above your int main portion. So the user can add a prototype above int main and define the function at the bottom, or the user can choose to define the function above the int main. I will be using a prototype, and then I will be a prototype above the int main, and I will be defining it below the int main. So now we're going to get into parameter passing. With parameter passing, the name of the variables do not need to match, although the types do. So here's our example. Here's our int main portion, and here's our function that we're calling. So our int main, the first line of code is we're creating a variable, and it's an integer, and we're giving it the value of 10, creating a second integer, calling it number 2, giving it the value of 20. So then we are going to make the call to add two numbers, passing in the parameter of number 1, passing in the parameter of number 2. So keep in mind these are both integers. So this is the first integer we're passing in. This is our second integer we're passing in. Now let's go to our add two numbers definition. So it's going to return an integer. We'll get back to that, but it's our add two numbers. That's our function call. And the first parameter we're passing in is number 1, and that's going to be grabbed, and I'm grabbing it and titling it num1. Now, we'll touch on this in more detail in the next video, but whenever we're doing something, and we're calling this a pass by value, you want to use different names. So for instance, over here it's titled number1, and over here it's titled num1. And the reason is, when you do a pass by value, it makes a copy of this variable. It does not pass in the actual number 1 variable. What that means is, if I were to pass in number 1 as a parameter, as I'm doing, and I were to, within this definition, make a modification to num1, it would not be reflected in this variable over here. What it does is it makes a copy. So the copy is being sent over, and whatever I do to the copy has no change to this variable over here. So we again have our first parameter being passed in, which is num1. That is equal to the number 1. And then the next parameter we're passing in is an integer of num2, and that would be our number 2. So then our return statement simply says we're going to add num1 plus num2. In this instance, it is 10 plus 20. It's going to return the value of 30. So within the cout statement, with all this entire blocker, or this entire function call here, the add two numbers with our two parameters, this here is going to return the value of 30. So what it's really doing is it's just saying cout 30. So it's going to display the integer of 30 back to the console. Here's an example of a void return type. So with parameter passing, the names of the variables do not need to match, although the types do. That's just a reiteration of what we said before. So again, I'm passing in number 1 and number 2. And so let's look at this. We noticed in the last one, I'll go back to it, we put a cout statement and we put our function call inside of a cout statement. The reason is because this function is returning a value. It's returning an integer. And I can put that in a print statement, in our cout statement. In this instance, we are not. We're just making a function call, and that is it. So we're creating our first integer, or our first variable, num1, value of 10. Second one is number 2, value of 20. And then we're making a function call passing in these two values. So we're going to go to the function, and we're going to execute all lines of code in the function, and then we're going to go and execute all code after the function call. So we jump over to our function, and now it's going to print something. So it's going to print, and it's going to print num1 plus num2. So num1 holds the value of 10 plus num2, which holds the value of 20. So it's going to cout 30, and then it has an end line character. After this function is completed, notice there is no return call. The reason there's no return call is because it returns nothing. It returns void. So that means that whenever you see a void, it's not going to return any value back to the user. So we just finished our last line of code in our add two numbers function. Then we jump back over here and we do a cout at the end with our endl. So what this would print in order, it would first create two variables. It would then make this function call. Inside the function call, it's going to print these two numbers added up, whatever two values we choose to pass in, and then it is going to end with the cout at the end. Something else that we could do, you can actually you can hard code the integer of 10 inside here, and you can hard code the integer of 20 inside here. You don't have to pass in variables. You can pass in actual integers. So again, a little bit more on functions. If the user is returning an item with a function call, you want to save it as a variable or print it. Otherwise, you are wasting it. Now, what that would mean is this here, this add two numbers, has a return type of integer. So if I were to just make the function call and I'm not saving it to a variable or I'm not printing it out, then you're kind of wasting your use of a return type. So if you're not storing it to a variable or printing it, then you'll want to use the void return type. So here's our example. Creating an integer, value of 10, creating an integer, value of 20, and now I'm creating a new integer, and it's going to store the value of whatever comes from the add two numbers. So we're adding two numbers, passing in the value of 10, passing in the value of 20. We already know what that function does. So this is going to be replaced with the value of 30. And now it's going to int new number equals 30. So that's an example of us using a function call and storing it to a variable. And then another use, so again, storing it to a variable, and then our other one being a cout call, it's just going to print the value of 30. Lastly, we're getting into a pass by value. When a function call is made, it is passing the parameter by its value. So that means that a copy of this item is being passed, and the copy is used. The original value is not adjusted or edited. The copy is passed into the function, and that is what is modified. So here's our for instance. We have num1 with the value of 10, and now we're going to print out, just so we can see that this holds the value of 10. Then we're going to make a function call, and the function call takes the value of 10 and it just simply adds a number to it. So when we make this function call, we're going to notice that our 10 becomes 11, but it doesn't actually modify what is stored in num1. So our examples being, this is going to see out the value of 10. This is going to see out the value of 11, because it's going to take our num1, it's going to go add 1 to it, and return that back to the user. So this will print out 11, and then we print out num1 again, and because we passed by value, this num1 was not edited. So this would print out the value of 10. So that's an example of pass by value. In the next video, we're going to be covering something called a pass by pointer and a pass by reference. Those are examples where you can make function calls and you can edit the actual value that you passed in inside that function. It is used, it's very important. I use it all the time. I love passing things by reference. And then again, this is our go-to page, so if you guys need any help, please reach out. Now we're going to get into our coding. So we want to make a new file, and I can already hear my computer whizzing up a little bit, so I know that it's going to be a slow one. So I will try to not compile that much, and we'll just do a lot of coding. So we'll call this functions, and we'll make it the CPP. So file and we'll functions.cpp. So first thing we want to do is include the input-output library. And then we want our function prototypes. Then we want our int main is used to begin the program. And then we want to create 2 ints. And then we'll ask the user to populate the ints. Now we can make a function call. So function call with a function call with return type of int. Oh, put way too much here. Okay, function call with a return type of int, and then we can do a function calls with return type of void. So we can see an example of that. And then we will return the value of 0 to end the program. Comment that out. And then we will program, and then we'll end it with our function definitions. Wow, this is riddled with errors. Value. Okay, so let's go through this one by one. We want to include IOStream, and I'm also going to do using namespace standard. I didn't even realize how dim that was. Function prototypes. Okay, well, let's create a whole slew of functions. So let's create one that just adds. So we'll have a return type of int. That's what it's going to return, and I'm going to call it add. And I'm going to add 2 numbers together. So int num1, int num2. So that is an example of our prototype. So now I'm going to do int multiply, or we'll do our subtract first. Subtract. And again, our two parameters that we're going to pass is just int num1, int num2, and close it, and then we'll do an int multiply int num1, int num2. Now we're going to create three more, but these are going to be of return type of void. So these will just have a print statement within. And we're going to call it print add. And of course it's going to have int num1, int num2. So I'm going to save myself some keystrokes, and I'm going to copy this. Paste, paste. So print add, print subtract, and print we'll just call it multiply. Okay, now I'm going to copy all of these. I'm going to put it all the way at the end, our function definitions. And I'm going to replace the semicolon with our curly braces. So this is where we define these functions. We're going to define them at the end. So this is all going to be on the outside of the int main. Sorry, function definitions. Let's make it look like that. So we have all of this before int main, and all of this is after int main. So let's now get into our int main. So int main, and it looks like that. Now let's copy all of this, and let's put it inside of our int main. I should cut, not copy. Okay, now create two integers. We'll just call it int number 1 and number 2. I won't assign it to anything. For those of you guys that remember on our first video, my integers on my compiler get auto-assigned to 0, so I'll just let the compiler take care of those, auto-assigning them to 0. I'm going to ask the user to populate cout, enter two integers separated by a space, and L, and then we're going to cin number 1, and then another number 2. So we are using our extraction operator, and this is going to grab the first item in the buffer, this is going to grab the second item in the buffer, and we're telling them to separate, and I spelled separate wrong, separate by space. So that's exactly what this will do. Grabs the first item, puts it in number 1, grabs the second item, puts it in number 2. Now we're going to make function calls. So let's do cout. When we add the ints we get, and then I can make the function call of add, and I'm passing in number 1, and then I'm passing in number 2, and then we will do an endl. So when we add the two ints, we get that. Let's copy this, and let's paste it twice, and then add, subtract, multiply, and then subtract, and multiply. So when we add the ints, we get, and then we call the add function. So this add function is going to add the two numbers together, and then it's going to come back and return its value in this position. So if I input 1 and 2, it's going to add 1 plus 2. This whole thing is going to return the value of 3, and that's going to be put into our cout statement. So I hope that makes sense. Next thing we're going to do is I'm only going to make function calls here. So the way I do that is I just do print add, and I'm passing in number 1, number 2. So that is us making a function call. And because this is a void return type, there's nothing to save it to, and there is no reason to print it. So the second one is subtract, and the last one is multiply. Awesome. And lastly, we always want to return 0. So now, looks like our int main looks good so far. Now let's go through and let's actually define these functions. So what I want to do is I want to return whatever value back. So I need to make sure that whatever I return is of type integer. Otherwise, it will give me a mistake. So if I were to do return and then input like a string like that, that would give me an error. I cannot return a string to an integer. Those do not align. So we want to return num1 plus num2. Easy peasy. And then return, now I'm subtracting, num1 minus num2. And then I'm multiplying, so that's just a return num1 times num2. And here I'm going to do a cout statement. Cout, let's do, now I don't want to copy the same thing because I want these to just print something a little bit different. Void function add to int, lowercase a, add to ints, oops, and then we will do num1 plus num2 and L. And then I'll copy this and we'll paste it into the other two. So add, now subtract, and lastly multiply. And we need to make sure that this is a subtraction now. We need to make sure that this is a multiplication now. So let's walk through this. I'm going to save it. I'm going to build it, but I'm not going to run it yet. So starting from the top, we have our include, which is our IO stream. Next we have our using namespace standard. And then we have our prototypes. So these are our prototypes. This is just telling it, because the compiler comes through and it's going to read everything sequentially. So it's going to go from top to bottom. So what's going to happen if I were to delete this, so if I were to do that, what's going to happen is it's going to go in exactly what just happened. These function calls, it's going to look at it and say, hey, I do not recognize what this is yet. Because it's going to come sequentially and it's going to say, I do not know what add is yet. And that's the same idea, is I can't use an integer that hasn't been created yet. So you have to create it first or tell it that it exists first before it can be used. So there we go. So by putting the prototypes at the top, it's just telling the compiler, hey, look, this exists. It'll be defined later, but it currently exists. So this is an example of us using prototypes. And then as we come down, we create two integers. We populate our two integers. Next, we are making a cout statement. Within our cout statement, we are making function calls. So we are going to add, it's going to make the add call, and it's going to add two integers, and it's going to return it inside the cout statement. It's going to do the same thing with a subtraction and a multiplication. Next, we are just simply making function calls. And inside this function call, it will execute all the code within this function call. Once it's executed all the code, it will then come back to its position where it left off, and then go to the next position, which is here. It will then go and execute this function. When it's done, it will return itself back to where it left off, which is right here, and then it'll go and execute the next line, in this line of code, and then it ends with our return 0. So again, everything that happens is going to happen sequentially in our int main. Everything that we want to do starts in our int main, and it's going to go through all of these lines of code, and when our int main is done, our project is done, our program is done. It will not get out of our int main and start executing these lines sequentially. These are all just helpers for our int main. That's how you can think of it. Now I want to give an example of us not using a prototype. So let's copy this, or cut it, and I can come in here and I will put it right there. That is an example of us not using a prototype. You have two options. You use a prototype at the top and then define it at the bottom, or you don't use prototypes at all and you only define it at the top. Personally, I don't like it. I am a prototypes guy, so for this you will always see me using prototypes. I think it's just cleaner, it's easier to read, and it's user preference, and I prefer it. So now we're going to run this. So build it and run it. My computer is going to be slow, so we'll let this take a couple seconds. It's never like this. Normally, the second you hit play, it's instantly ready. So enter two integers separated by a space. So let's do 100, and then we'll do 5. Enter. When we add the two ints, we get 105. When we subtract the two ints, we get 95. When we multiply the two ints, we get 500. So all of these were examples of this here. We are making it in a cout statement. We are making a function call, within our cout statement, and we can do this because these all have return types that are not void. They're all int return types. Now the next thing we have here is we are just making 3 function calls. These 3 function calls will go and execute all the lines of code within each function. That is this example here. So void functions, when we add 2 ints, we get 105. When we subtract 2 ints, we get 95. And when we multiply 2 ints, we get 500. Awesome. Let's just play it one more time. Oh man, it's so slow. So now I want to put a smaller number first. Last time I did 105, so I put a greater number in the front side as our number 1, and I put a smaller number for our number 2. Now let's swap it. So let's do 5 and 100. So again, for our ints, we get 105. When we subtract, we get negative 95. When we multiply, 500, and again, repeated. When we add, we get 105. When we subtract, we get negative 95. And when we multiply our 2 ints, we get 500. So I hope this all made sense. This is an example of our return types, parameters, functions. Functions are used all the time, so it's really important that we're comfortable with them. It's heavily used when you want to repeat code, and we will get a lot more examples of functions. It's pretty safe to say that a function will be used in just about every single video that we do from here on out. And again, our next video will be on pass by reference. We'll be on pointers, pass by pointers, and pass by reference. So that's going to be a lot more of functions and how you can make functions a little bit more powerful. I hope this all made sense. And again, if you guys have any questions, do not hesitate to reach out.